Alright, so let's look at the second theorem. If we have a parallelogram, then the diagonals bisect each other. Alright, so if we go back to this list of theorems, this theorem 2 will enable us to reason why this is true. Why is it that if you have the diagonals bisecting each other of a quadrilateral, then it becomes a parallelogram, right? And like I've stated before, this is the theorem. What becomes more useful here is actually the converse, because if you have the diagonals of a quadrilateral bisecting each other, then we can conclude that a quadrilateral is what? A parallelogram. And so what we are required to prove is that, only after construction you'll be able to see this, is that AE, this one here, is equal to EC, this here, this line segment, and BE, this here, is equal to ED, this here, right? And so if you're given a parallelogram, you need to construct the diagonals of this parallelogram and call it AC and BD, right? Now we need to strategically choose two triangles. How do we strategically choose it? It's basically the triangles that make up these diagonals here, right? So that's what you need to remember. It's the triangles that make up the diagonals. Okay? If we go back to theorem 1, we chose triangles that made up the two sides of the parallelogram. If you look at this theorem 2, we are choosing triangles that make up the diagonals. So that's the difference between what you're choosing, right? So keep that at the back of your mind. And so that's the reason why I chose ABE and CDE. Right, remember, this lettering doesn't matter. Only at the end we need to be a bit more specific about what we choose. So firstly, we can say that A2 is equal to C1 here because of alternate angles, AB parallel to CD. Then we can say that B1 is equal to D2. Can you see that? Because of alternate angles, there's the Z shape here. And we can say that what? This is AB parallel to CD, alternate angles. And then we can say that AB, this side here, is equal to CD, the side here. And so what we've used now is an angle, an included side, and an angle. So from the 5 conditions that I taught you, side, 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 angle, side, angle, side, angle, 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 side, and right angle hypotenuse side, we made use of the third condition. And so how do we name these triangles? In triangle 1 and triangle 2, A matches with C, B matches with D, and we can say E from triangle 1 matches with E from triangle 2. And so I went A, B, E, and then I went C, D, E. Can you see how we're listing it in order? And so if we look at the relationships between AE, see, AE, first and last, is equal to what? First and last, EC. So from your congruency statement, I proved the first part. Let's look at the second part, BE. Second and third, second and third. So B is equal to ED. Yes, in fact it is. And so we proved the second part. And so using this congruency, we were able to prove that these here are equal. Are in fact equal. And we proved that the diagonals bisect each other. Right? So that's what's the significance of it. Now, what you must remember is that to prove theorem 2, we can use theorem 1. However, to prove theorem 1, we cannot use theorem 2. Can you see this part here where we said that AB is equal to DE, the opposite sides of a parallelogram? Remember, we proved that in theorem 1. So from theorem 1, you can use it for theorem 2, but you can't go in the opposite direction. You can't say that the diagonals bisect each other. This is why I said again that the mathematicians thought about this strategically. They put this here first for some specific reason. So we're just using these ideas, understood? So that's the reason why we have to teach opposite sides and angles of a parallelogram to be equal first and prove why that is the case in order for us to use it in theorem 2. Understood? Because these ideas will lend itself. So yeah, and this idea is relevant even at grade 11. You can only use theorem 1 to prove theorem 2. You can't use theorem 2 to prove theorem 1. Okay. And so that's how we prove theorem 2. Again, if I just want you to re-emphasize something, is that when we are choosing triangles for theorem 2, we choose the triangles that make the diagonals. But when you're choosing a triangle for theorem 1, we choose the triangles that makes the sides of the parallelogram. Right, it made these sides. And then obviously the diagonal will be the third side of the triangle. Okay,